Hello students, welcome back to my channel. Today we are starting class 10 Maths, chapter number 1, Real Numbers, and we will focus on exercise 1.1. If you are new here, this chapter is specially for school students where I explain concepts in very simple and easy way. So before starting the video, please subscribe my channel. Now, I am going to explain first question. Express each number as product of its prime number. In that first one is 140. So this 140 we have to express in the product of smallest prime number. That means we have to divide by the smallest prime number which is possible. This is a even number, so we can divide it by 2. 270 is a 140. Then again it's a even number, we can divide it by 2. 235 is a 70, then we can divide by 5. 5 sevens are 35, 7 ones are 7. So we can write it as 140 is equals to 2 into 2 into 5 into 7. 2 times is there, so we can write 2 to the power 2, 5 into 7. This is a product of prime factors, that is 2 square 5 into 7. Next question is 156. Again we have to divide from the smallest prime number, that is 2, because it's a even number. 2 sevens are 14, 1 remaining, 2 eights are 16. Again we can divide by 2, 2 threes are 1 remaining, 2 nines are. It is not a given number, so we have to choose other number, that is 3. 3 ones are 3 threes are. Now 13 is a prime number, so we can divide by only 13. 13 ones are. So its product is 156 is equals to 2 into 2 into 3 into 13. This also we can write it as a 2 to the power 2 into 3 into 13. It is a product of prime factors. Now third one is 3825. This is not a even number, so we cannot use 2 as a factors here. So at the last 5 is there, so we can use 5 to divide it from starting. So I'll use 5 here. Now 5 sevens are 35, 3 remaining, 5 6 are 30, 2 remaining, 5 fives are 25. Again at the end 5 is there, so I'll use 5 only. 5 ones are 5, 2 remaining, 5 fives are 25, 1 remaining, 5 threes are 15. Then I'll use 3 to divide it. 3 fives are 15 and 3 ones are 3. Again I'll use the 3 to divide it. 3 ones are 3, 7s are. 17 is a prime number, so directly I'll use 17 only. 17 ones are 17. So the product of these factors are 5 into 5 into 3 into 3 into 7. This I'll write it as a 5 to the power 2 into 3 to the power 2 into 17. This is the product of its prime factor, that means 3825's product. Next we will go to next question, that is 5005. Fourth one is 5005. Here at the last again 5 is there, so we can use 5 to divide it from starting. So I'll use 5. 5 ones are 5, then 2 zeros are there, then again 5 ones are 5. Then we have to check the smallest number which can divide it. That means 1001 divided by 7. So I'll use a 7. 7 ones are 7. 3 is remaining. 7 fours are 28. 2 is remaining. 7 threes are 21. So again we have to check the smallest prime number, that is 11. We can divide it by 11. 11 ones are 11. 3 remaining. 11 threes are 33. So 13 is itself a prime number, so we have to divide by 13 itself. 13 ones are 13. Now 5005 is equals to 5 into 11 into 7 into 13. It is product of its prime factors. So we'll go to the next question. That is a fifth one is 7429. 7429. In this number, from the starting of prime number, we have to check which number can divide it by. So we have to check 2, 3, 5, 7 like this prime numbers. It will be divided by 17. So we have to check by 17. When we divide it by 17, we will get 437. 17437 are 7429 will get. Again we have to check from the starting prime number where it will be divided. So we'll get it divided by 19. So 1923 is it will be get divided. 23 itself it's a prime number, so we have to take 23 only. 23 ones are 23. So 7429 prime number is 17, 19 and 23. 17 into 19 into 23, it is a product of its prime factors. This is how we have to find any numbers products. Now we will move on to next question. Next question is find the LCM and HCF of the following pairs of integers and verify that LCM into HCF is equals to product of the two numbers. So here the first question is two pairs are given, that is 26 and 91. Here again we have to follow to find its products. That means 26 is divided by smallest number, smallest prime number, that is 2. I'll find the product of 26. 2 13s are 26. So 13 is a prime number, so I'll directly divide it by 13. 13 ones are 13. Now 26's products are 2 and 13. The next question is 91. 91 is divided by it by smallest prime number is 7. So 7 13s are 7 ones are 7. 2 is remaining. 7 threes are, so 7 13s are 91. 13 ones are 13. So now we here get 91's product, that is 7 and 13. Next step is find the HCF of a given number. HCF is a highest common factor. In the both the number, which one is repeated in every time, that is 13. So HCF is 13 here. Highest common factor is 13. Next is the least common factor, that is LCM. So the number which is are there in the both the numbers, that is the least common factor. 2, 7 and 13. These three numbers are there in the 26 and 91 factors. So we have to multiply these three numbers. So we will get 182. 182 is a LCM and 13 is a HCF. Then they asked to verify LCM into HCF is equals to product of the two numbers. LCM into HCF is equals to product of two numbers, means which two numbers are given, that we will consider as A into B. This is a formula to verify the answer. LCM we got a 182 into HCF is a 13 and A into B means what the two numbers are given, that is 26 into 91. When we multiply 182 into 13, we will get 2366. Same as it is in the right hand side also, we will get 26 into 91 is equals to 2366. So while verifying, we have to get LHS is equals to RHS. Then only we can consider as our LCM and HCF answer is correct. Next we will move on to the next question, that is 510 and 92. Now we have to find the product of 510. So I'll take smallest prime number as a 5 to divide it. 5 ones are 5. Then 1 is there, so I have to take 0 here. Then 10 together, that 5 twos are 10. Now I will take 2 to divide it. 2 fives are 2 ones are. 51 is divided by 3, so I will take 3 ones are 3, 2 is remaining, 3 sevens are 21, 17 itself is a prime number, so 17 ones are 17. So product of 510 is 5 into 2 into 3 into 17. And again one more number is there, that is 92. I have to find out the product of 92 as well. 92 I can divide it by 2. 2 fours are 8, 1 remaining, 2 sixes are 12, again I can divide it by 2. 2 twos are 2 threes are 23 is a prime number, so directly I divide it by 23. 23 ones are. Product of 92 is 2 into 2 into 23. Now the HCF is it must be there in the both the number, that means 510 and 92. Which number is that? Is 2. 2 is there in the 510 as well as 92. If you consider 5, 5 is there only in the 510, it is not in the 92's factors. Then again 3, 3 is not in the 92's factor. 17, it is not there in the 92's factors, and 23 also not there in the 510's factors. So answer of HCF is 2. LCM means it must be there in the both the numbers. First, if you consider 5, 1 time 5 is there, right? That we have to write. 2, where the 2 is repeated more time, that we have to write 2 into 2. Then 3, 3 is there only one time, that one time we have to write. Then 17 as well as 23. These are the LCM. If you multiply this all together, we will get 23,460. This is a LCM of a given number. Now we have to verify it is correct or wrong. To verify, the formula is LCM into HCF is equals to A into B. A and B means 510 and 92. So LCM what we got 23,460, that we have to write down. In the place of HCF, that is 2. And when multiplying this, we have to get A into B, that means 510 into 92. The LHS, while multiplying this, we will get 46,920, as well as RHS also we have to get the same number. We will get the same number, that is 46,920. So if you get both the sides same answer, our answer is correct. Next we will go to the third one, that is 336 and 54. Factors of 336 are, first we will divide it by 3. 3 ones are 3, 3 ones are 3, 3 twos are 6. Then we will go to the 2. 2 fives are 10, 1 remaining, 2 6 are. Again by 2. 2 twos are 2 eights are. Again by 2. 2 ones are and 2 fours are. Then again 2. 2 sevens are 14. 7 is a prime number, so 7 ones are 7. So factors of 336 are 2 in 3 into 2 into 2 into 2 into 2 into 7. Then one more question, one more number, that is 54. 54 we can divide it by 2. 2 twos are 4. 1 remaining, 2 sevens are 27 is a 3 is a product, so we can divide it by 3. 3 nines are 3 threes are 9. 3 again we can divide it by 3. 3 ones are 3. So product of 54 is 2 into 3 into 3 into 3. Now the HCF is the number must be there in the both given numbers factors. So which number is both in the factors? So one number is 3. It is in the both factors 3. Another one is 2. This also in the both factors. So 7 is not there in the 54th factor and 3 is only one time is there. So the answer is 3 into 2, that is 6. LCM is the number where it is repeated more time that we are considering. 2 is repeated 4 times. So 2 into 2 into 2 into 2. And next 7. 7 only one time is there. So into 7 and 3. How many times 3 is repeated? 3 times. 3 into 3 into 3. When we multiplying these all numbers, we will get 3024. So this is a LCM. Now we have to verify it's correct or wrong. Verification is HCF into LCM is equals to A into B. What is HCF? HCF we got 6 into LCM 3024. In the place of LCM we have to write that. A into B, we know that 336 into 54. When we multiplying left hand side, we will get 18,144. Right hand side also we will get the same number 18,144. When we get the same numbers in the both sides, our answer is correct. So we will move on the next question, that is find the LCM and HCF of the following now integers by applying find factorization method. The numbers are 12, 15 and 21. In these three numbers, we have to find the factors of all three numbers separately. We cannot find out the factors directly, so we have to do the prime factorization method. So the first number is 12. The smallest prime number we have to consider to divide, that is 2. 2 6 are 12. Again we can divide 6 by 2. 2 3s are and 3 1s are 3. So the factors of 12, 2 into 2 into 3. Then the next number is 15. So we will find out the factor of 15. We can divide it by 3. 3 5s are and 5 1s are 5. So the factors of 15 is 3 into 5. Then the next number is 21. Factors of 21, it can divide by 3. 3 7s are 7 1s are. So factors of 21 is 3 into 7. Now to write HCF, HCF is we are writing the numbers which is must be there in the factors of all three numbers. So 3 3 3. It is there in the factors of all three numbers. If you want to find out the 7. 7 is not there in the all the factors and 5 also not there in the factors of all the numbers. So 3 is the HCF. Then LCM. LCM is the number which is repeated more times in the factors of all numbers. For example, in the 12th factor, 2 is repeated 2 times. So 2 into 2. Then 3. 3 is repeated only 1 times. Then the 5 and next is a 7. So if you multiply all this number, we will get 420. So the LCM is 420. This is finding the HCF and LCM through the prime factorization method. Next, second one is numbers are 17, 23, 29. If you observe this number, these all three numbers are prime numbers. These all numbers are itself a prime number. So 17, it's divided by only 17. 17 ones are 17. Next 23 also a prime number. So 23 is divided by only by 23. 29 also same. The factors of 29 is 21, 9 and 1. So if you want to write the factors of 17, it's 17 into 1. Next factors of 23, 23 into 1. This only the factors. Next factors of 29s are 29 into 1. So now what is HCF? HCF the numbers which is a must there in the all the factors. So 1 only is a common factor in the all. So HCF is a 1. Next is a LCM. LCM is a number. It is a comes most of the time in the numbers. So 17 into 23 into 29. So when we multiply this, we will get 11,339. So HCF is 1 and LCM is 11,339. Next, third question is 8, 9 and 25. We have to find out the factors separately. First 8's factor. 8 is divided by smallest factor, that is 2. 2 fours are again from the 2. 2 twos are again from 2. 2 ones are 2. 8's factors are 2 into 2 into 1. Then factor of 9. 3 into 3 is 9. Again 3. So the factors of 9 are 3 into 3. Then the 25. 25. 5 fives are 25. Again 5 ones are. So factors of 25 are 5 into 5. Then if you observe this number, the common factor is only 1. Again we'll get the HCF is HCF is equals to 1 because the number repeated in all the factors, that is 1 only. Next LCM. So we have to write in the LCM place 2 into 2 into 2, 3 into 3, then 5 into 5. When we multiply 2 into 2 into 2, we will get 8 and 3 into 3 9 and 5 into 5 25. So when we multiply all these number, we will get 1800. So this is the LCM and HCF of 8, 9 and 25. Fourth question is given that HCF of 306, 657 is equals to 9. Find LCM of 306 and 657. This is given that A and B is 306 and 657. So we know the verification method, that is HCF into LCM is equals to A into B. A into B is given in the question and HCF also given in the question. We have to find out the LCM. 9 into LCM we don't know, so we have to write LCM as it is. A is 306 and B is 657. After substituting this, we have to find out the LCM. LCM is equals to, when we multiplying 306 and 657, we will get 2,01,042. And when the multiplication 9 comes to right hand side of the equal sign, it is dividing. When we divide this number by 9, we will get LCM is equals to 22,338. If any number is given like this, we have to do the verification method to find either LCM or HCF. What is given, that you have to subtract in the given place. Next, fifth question is check whether 6 to the power n can be end with the digit 0 for any natural number n. So in this question, we have to write the factors of 6. Factors of 6 is 2 into 3. Any number is given like this. For example, here it is given 6 to the power n. If any number is given like that, 12 to the power n. So we have to write the factors of 12. So any number is given, if the 5 is in the factors of that number, then only it is end with the 0. If 5 is not there, we have to consider that that number is not ended with the 0. In the 6 power n, the factors are not 5. So we have to write no, 6 to the power n is not end with 0. Why? Because we know that in the factors of 6 there is no 5. So we have to write because to get 0 we need another factor. To get 0 we need another factor, that is 5. In the sixth factor, there is no 5, so it is not end with a 0. This much is the answer for this question. If any number is given, you have to write the same sentence and factors are only the change. Next, explain why 7 into 11 into 13 plus 13 and 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 are composite number. So here to find out this one, first we have to find the product of 7 into 11 into 13 and we have to add 13 to the product and same to the second number also. We have to find the product and add 5. Now before that we should know what is prime number and what is composite number. So prime number means the number which has a factor 1 and number itself. This is called as prime number. For example, if you consider any number like I'll consider a number 7. If you find out the factors of 7, you will get a 1 and a 7. 7 is divided by 1 and 7 only. And one more example I'll consider 13. If you consider 13, it's divided by 1 and 13. So which number is divided by 1 and the number itself, it's called as prime number. Next is a composite number. Composite number means it is divided by or the factors of composite numbers are 1 and number itself and also other numbers also. For example, if you consider any numbers like 14, I'll consider number 14. It has a factors of 2, 7, also 1 and 14. These are the factors of 14. I'll consider one more number, that is 15. 15 is divided by 1 and 15 as usual. Then 3 as well as 5. So here the factors of 14 and 15. One number itself and other number also is there. It is called as composite number. So we have to prove the given numbers are composite number. Now I will take the first numbers, that is 7 into 11 into 13 plus 13. I'll multiply the first numbers, that is 7 into 11 into 13. We will get 1001. Then plus 13 is equals to 1014. So now we have to find out the product of 1014. 1014 is an even number, so we can divide it by 2. 2 5s are 1 is not divided, so 0. 2 7s are. So this is divided. 507 is dividing by 3. 3 1s are 3. 3 6 are 18. 2 is remaining. 2 9s are 3 9s are 27. So 169 is a square number. It is a square of 13. So 13 into 13 is 169. Again 13 is divided by 13 itself. 13 ones are 13. So factors of 1014 is equals to 2 into 3 into 13 into 13 into 1. These are the factors of 1014. Now the next number is given, that is 7 into, we can write the second number, that is 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5. First we have to find out the product of these numbers. When we multiply these numbers, we will get a 5040 plus 5, that is equals to 5045. So we have to find out the factors of this number. 5045, at the end it is 5, so we can divide it by 5. 5 ones are 0, 0 and 5 nines are. 1009 is a prime number, so we have to divide it by 1009 only. 1009 ones are 1009. So the factors of 5045 is equals to 5 into 1009. So here the number itself 1 and other than also numbers are there in the factors. So if the number itself 1 and other numbers are there in the factors, it is considered as a composite number. So we have to write both are composite number. What are the numbers are given in the question? Both are composite number. This is a way to explain why it is a composite number. Now the next question is, there is a circular path around sports field. Sonia takes 18 minutes to drive one round of the field while Ravi takes 12 minutes for the same. Suppose they both start at the same point and same time and go in the same direction. After how many minutes will they meet again at the starting point? Now the question is, two children are moving in a circular path. One girl takes 18 minutes to complete one round, but a boy takes 12 minutes to complete one round. That means when she complete one round, he may be here only. So the next second round also same, but he will not reach same as that girl. So here the question is, how much time they took to come the same starting point together. So here we have to find out the time. We are using LCM. I'll explain at the last why we are using LCM, not the HCF for this question. Now LCM of 18 and another one is 12 minutes. LCM of 18 and 12. We have to find out the LCM. To find this, we have to find the factors. First, factor of 18 is 2 9s are 18, 3 3s are 9, 3 1s are 3. Next, factors of 12, 2 6s are 12, 2 3s are 3, 1s are. So the factors of 18 are 2 into 3 into 3. Then factors of 12 are 2 into 2 into 3. So LCM is equals to 2 into, so 2 is repeated 2 times, 2 into 2, and 3 also repeated more means 2 times, 3 into 3. 2 into 2 4 into 3 into 3 is 9, 9 fours are 36. So they take 36 minutes to reach the starting point together or meet again in the starting point, at the starting point. So the conclusion of this question is, therefore Ravi and Sonia will meet together at starting point starting point after 36 minutes. So now why we use LCM not HCF, and how we get to know where we have to use the LCM and where we have to use the HCF. So this is one of the main important thing in this chapter. The application based question will be given from this chapter. So we should know when we have to use the LCM and when we have to use the HCF. How we get to know? That is, here Sonia completes one round in 18 minutes. Ravi completes one round in 12 minutes. They start together and we want to know when they meet again at the starting point. They will meet at the starting point only when both completes whole number of rounds together. So we find common time when both finish rounds together. That is why we use LCM, that means least common multiplies. What happens if we use HCF? HCF of 18 minutes and 12 minutes. When we find the HCF, we will get 6. But after 6 minutes, that means if they move only 6 minutes, Sonia has not completed one round, as well as Ravi also will not complete one round. So they won't meet at starting point. That is why HCF is wrong here. So now we should know, right, when we have to use LCM and HCF. So use LCM when you need common time, repeat together or meet again. For example, two people running around track when they meet again, or two bells ringing when it ring together again, or two buses leaving when it arrive together, or two machines working when it completes the work together, like together, again, meet again, same time, simultaneously. So this all times we have to use a LCM. Now, when we have to use a HCF, use HCF when you need maximum equal grouping or divide into equal parts. For example, divide chocolates equally, or arrange students in equal rows, or cut ribbons into equal pieces, or largest number that divides both, like maximum, largest, equal groups divide equally. This is a way you have to use how LCM and HCF. Like LCM is together, repeat, meet again, and HCF is divide, group, largest. In these times you have to use the different things. That means LCM and HCF. This you should must know, because in the question, that means in application based question, they will not mention you have to find LCM or HCF. They will give just the questions like the seventh question, and you have to think here you have to use LCM or HCF. Now I think the topic is clear to you. So please subscribe my channel, support me.